All right, so we are back with another session of the Blockchain Community Day Conference 2026, and I'm very happy to invite our good old friend Sasha Baksht from Here Learn Club. Hello, Sasha. How are you?
Hello, hello. Good morning. Pleasure taking part in this conference once again and again. And everything is good at my end. How is conference doing so far?
Yeah, that's great. Really interesting what's happening in 2026, and a lot of insightful talks, insightful solutions are being presented. Really happy to see you here again and again. I think you are one of the most earliest speakers at our conference since the very beginning, when the conference has been launched back in 2020 or something. I don't even remember. And yeah, before we start, just a couple of words about yourself, and after that, we can start the presentation.
Yeah, time flies. My name is Sasha Baksht, and I've been in education and technology for more than 2 decades. And today is my topic. My topic is about how to deal with the ice swap and dramatic decrease of trust in the AI era, right? Like we cannot get it back. I came into our life and it's gonna stay, regardless we want it or not. Like it's there, and we have to deal with that.
Yeah,
Yeah,
that's what we have nowadays. And yeah, I think without further ado, you can start sharing your screen and we are good to
absolutely.
start.
Let me set it up.
Yeah, we will be sharing the screen instead of a PDF, but still, I think it's here. Uh-huh. Yeah, for some reason
Yeah,
it's
awesome.
it has this black lines. Mm, Is it
Let me hold on. Let me figure it out.
is your screen in the vertical? Oh, yeah, now it's much better. Now it's full screen. Mhm. Oh yeah, could
Yeah,
you please turn it back?
now it should be good, right?
Yes, now it's great.
Okay, okay, cool. Okay, so I'm founder of Learning Club, leading all-inclusive hands-on community learning on near protocol, and let's talk about trust, about the history of trust, about the problem of trust today, and what are solutions that we already have as a proof of concepts, and helping people to figure out how to deal with the trust in the IAR. The history of trust, right? What is basically trust? Like it's been trust is the uh, fundamental mm, uh, thing in the human relationships, right? Like the people need to know like who said what, who said this, where did it happen, and how can I trust it? And back to the ancient era, the humans were dealing like just like in real life as we call it today. Like people were having personal relationships and they were talking in front uh, one of another with other folks who can verify it and confirm like this is what right, they do. Uh, the leaders, like the rulers of the world, they were using their personal rings with with their stamps, and they could use it to, like putting it on into hot wax on letters, kind of to verify and to confirm that they actually did sign this particular letter and stuff. Like armies, like for the in the operations, like when they were trying to protect their villages and their fortresses. They used watchwords that they changed every other day, or depending on their cadence. So and that was the way. Later on in the industrial era, when paper becomes more and more common uh, in everyday lives, uh, and when the printer was invented, the people start using their own stamps, not just the rulers, but they like business people and legal people. They're using stamps to confirm their papers, and they will also using serial numbers to create kind of limited edition of anything, including banknotes and stuff like that. And I, I I do skip the uh, internet era and the technology era just to showcase how dramatic the changes are nowadays. Like, uh, yeah, this is me. That's my heritage. And with me, say like some 40 years ago, maybe even more. And this image was created by Grok, I guess. Like, oh no, not by Grok, by Gemini. And it took about 1 minute or even less to get it. And you see, like, it looks like legit, right? Like, so taking this into account, everyone has to consider that there is like no photo, no screenshot, no video, article, post, or comment can be verified without signature, right? Everything can be faked like in a matter of seconds. And there is like kind of continuous battle between fakers and investigators, but detection only approaches it's a it does not work, right? Because generative models improve continuously, and they're staying way ahead of classifiers who try to spot the fakes. And when we switch to the AI itself, like charts, agents, and stuff, it becomes even more scary because you have no idea whom you're talking to, right? Like, what's the model? Like, what's the data set this model was trained on? What are the settings? What is the system prompt and stuff like that? So basically, you have no idea, like when you deal with AI or when you deal with digital documents and digital artifacts, you have no idea is it true or not, and how can you trust? Like by default, like you cannot, right? And without trust, it's super difficult to operate in digital world. It's super difficult to operate in real world, and everything becomes like too expensive and too slow because like half of your efforts or even more you have to spend on due diligence and investigation stuff. So, what could be a solution for this trust declining problem. And my touch on that is pretty simple, right? It's like you you could call it philosophical. Like the probabilistic AI and deterministic blockchain, they're kind of friends together, right? They do need one another, and this is how we can approach the trust issue in the AI era. Uh, and the fundamental technique underlying all blockchain authorization services is elegant in its simplicity. Rather than storing the entire document on chain uh, and exposing them to the entire world, right? You just store a cryptographic hash on it, like unique digital fingerprint of the document, whatever document is. It can be PDF file, it can be photo, video, whatever. It can be set of hashes even, right? And what does this approach gives us? It provides us proof of existence, like it controls the fact the document existed at or before the timestamp of the transaction blockchain. It provides a proof of integrity that the document has not been changed since it was stamped, and it provides us with decentralized verification. Everyone can, with the hash uh, stored on a public blockchain in plain text, everyone can reproduce the hash, right? Like if you know how the hash functions works, like literally, like it generates a fingerprint that is is unique. It is impossible to generate similar fingerprint for edited document and stuff. And another important feature of that is provenance. Like we can actually verify who actually signed the transaction and who created that stamp. All right. I hope uh, you got a brief understanding what I'm talking about, and let's switch to the real world use cases. Uh, and you might be surprised, right? But the history of putting hashes on public blockchains is quite long already. It's like more than 10 years, I guess. And the applications vary from art to aerospace and agriculture. The very first one, and probably not the very first one, but the one that can be considered as a G in timestamping services is Open Timestamps. It's a foundational open source protocol developed by Bitcoin developer Peter Todd. And this is how it works. Like a user hashes the document using SHA-256 function and submits the hash to public OTS calendar server. And then all the hashes from in particular period of time they get batched into Merkle tree, and that Merkle tree enters the root of Bitcoin block. And the user, after all, receives a tiny OTS receipt file, and verification requires only the original document and the receipt. Like no trust in open timestamp services needed, as verification can be done against any Bitcoin full node. And this service is used by legal prior arts in scientific priority, journalism, and document integrity, and so on. Okay, let's go next. And as I talked, oops, as I talked before, the one of the first and obvious use cases uh, for the timestamps on blockchain is art, like an artist, especially popular artists or famous artists, as they actually do care about how to prove that this particular artwork or this particular idea belongs to them, right, and originated from them. So the one of the most popular verification platform for the art and artists and galleries is called Verisart, and this is how it works. Artists create a certificate of authenticity on Verisart, provides title, medium, year, dimension, and the image of the artwork. These certificate details are hashed and anchored to Bitcoin blockchain via OpenStames, the project that we talked previously. And the issuer identity is verified through Verisart KYC process, know your customer process, a critical addition, since blockchain alone doesn't verify the identity of the person uh, making the claim. And once the artwork being sold or donated, the ownership transfers on ownership transfers is recorded on chain as the work changes hands. Optionally, the platform provides artists with the ability to issue an NFT certificate on Ethereum Polygon blockchain. Cool. What's next? Now, we talked about document hashes, timestamps, and now it's time to switch to the problem how people approach verification of AI models themselves. one of the leading project near cloud. They run frontier open models inside hardware security enclaves called TE, trusted execution environment, and the communication between you as a user and LLM as the service provider is encrypted over ITS protocol, and the hardware signs the proof that you're dealing with this particular model, with this particular settings and stuff, and so on. So what does it give us? It gives us 100% 100% verification that you deal with this particular model, with this particular system prompt and stuff, and your data is not exposed to anyone else. Like even the model itself, like even the owner of the trusted execution environment uh, infrastructure, they cannot access to your data, right? So it's like it's completely secured and completely verifiable. Okay, and before we go to the one of the projects that we initiated Learning Club and Stamp, I will tell you why we actually decided to use NEAR for this project, and it's pretty obvious, like because NEAR has human readable accounts and sub accounts and stuff like that. It is understandable. And it creates the option to to verify the provenance of and stamps being created. Neural is also a sharded blockchain from day one, that which means unlimited storage, like virtually unlimited storage. And for the future neural integration, where we can combine and stamped documents with verifiable AI inference, it makes the entire cycle of interacting with the AI uh, almost completely verifiable. Okay, so this is how the first version of Stamp works. Uh, Current implementation, version 1, keeps the architecture deliberately simple and auditable, combining two verification mechanisms. Which one is client-side browser hash, and files are hashed entirely in the user's browser using the function SHA-256, and that means that the files and they never leave the user device, and there is no server large resources involved in the computation. Both this is both privacy guarantee and reproducibility feature, because everyone can easily recreate the hash that being timestamped on near blockchain. So near blockchain anchoring the hash is written to near protocol blockchain via signed wallet transaction linked to optional link to the user on-chain identity. Second finality of near protocol is very important to very important to mitigate the possible alters to the source, right? Because like it's the if when we talked about times open timestamps on Bitcoin, like it can take like from like 15 minutes to half an hour, even longer to get actually the Merkle tree incorporated in the Bitcoin block. When we talk about near blockchain, like it's matters like below a second. And another interesting thing that we use is near domain system verification, which binds the application domain. In our case, it's .and stamp XYZ to the smart contract, which is v1 and stamp.near on chain, which prevents impersonalization attacks where malicious clone could fool users into stamping to fraudulent contract and stuff like that. Uh, we went even further, and there is a very interesting project here in Toronto, like in GTA area, certain by our friends Inference Labs, and this is what's cool about it. The certain parts they solve the Duran problem. They proven that an AI model run correctly and produces a specific output. They they have a history working with aviation operators on real-time computer vision across runways, terminals, and so on. And together with Nstamp, uh, we form a complete evidence chain of AI-assisted workflows. And for this, I decided to use not uh, space area, but the agriculture area to demonstrate how it works and on solving problems like that that affects every user here, right? So, and this is a image of taken from the certain backend, and the model was trained on tomatoes and figure out like which ones are good to go and which ones are still green. Right? Okay, and this is the attestation of the model, and combined with the image itself. And once certain generates a cryptographic proof, and the model M produce that model M produce output O from input I, the proof artifacts itself a file, right, and can be immediately anchored to the near blockchain via Nstamp. So, and this is the attestation and uh, file, uh, and it consists of a file name and a hash transaction and so on. So everyone can verify the hash at near Explorer, and you can see here the hash itself, the transaction, the time of transaction, and so far. So certain inference proofs guarantee computation correctness, but do not inherently timestamp result to a decentralized ledger. And combined with Nstamp, we cover both gaps, and because near transaction costs are very, very low, and creating certain proof artifacts for instance as effectively zero overhead to the inference pipeline. Like that, again, like new transactions are very affordable, are very fast, and we literally have unlimited chain, unlimited space on near blockchain. Pretty affordable. Cool. So now we can see that with the approach that we take in STEM, we can answer the questions: who said what, when did they do this, and how we prove it. So luckily we are on the right path to figure out how we can add more trust in our road, and how we can coexist together with artificial intelligence, and not just coexist, but also efficiently communicate, cooperate, and collaborate with artificial intelligence. Thank you.
All right.
Hello.
So, yeah, thank you so much, Sasha, for bringing this use cases, real world use cases, and all the information about the era that we live in right now. And yeah, that was very interesting for me to see those real use cases that you presented, and I didn't know about most of them and wasn't deep into the topic to that degree. But still, it still feels like it is some kind of niche thing. It's not massively adopted. And what do you think are the main blockers right now? And when will we get more and more normies into this?
Yeah, this is what most of the people that I talk to tell me, and the point is like the you don't need it until you need it. And like one of the casual anecdotal case for me, I just got a ticket, right, from a parking ticket in Toronto, and I came back home and submitted this ticket to dispute it. It's like it wasn't that fair, right? And I didn't receive any confirmation. I didn't receive any email or anything, just a screen. So I took a screenshot, I stamped it, and now I have at least something, right, to prove that I submitted my claim. Otherwise, like they could tell me, like you can, yeah, it didn't exist. You didn't submit it at all. But yeah, at least I have proof of existence. And when you extrapolate that further, right, to the manufacturing process, to legal process and stuff like that, right? Many times people need to prove the sequence of the actions or the sequence of development for documents or for products for anything, to their customers, and having stamps brings a little bit of trust, and the more trust, the easier and cheaper make business transactions, right, and human transactions as well. So we are getting there. I know it's a little bit earlier, but this is a new big thing. Trust me. But
Yeah, I
verifiable.
like the approach about you don't need it until you don't until you need it. Yeah,
Exactly. Same
it's
for the
interesting.
crypto, right? You don't need it. Yeah, but you need it
Yeah,
when you need
simple.
it. Yeah,
And
yeah. Thanks God it
is
exists.
there? Yeah, technologically everything is ready and it exists already. Is there any specific reason why near as a layer one blockchain is probably relevant and convenient for it, or maybe other layer one blockchains are also suitable, or yeah, any specific reason how near ecosystem is do you think is suitable for it?
Yeah, the most important reason is that near is a sharded blockchain, right? And for stamping uh, data, right? For stamping data transaction, not financial transaction, it's important to have affordable space on blockchain itself, right? And if we code here for layer of trust for financial transactions, right? Near has very good chances to become blockchain for trust for data transactions. Because like it's too expensive to store uh, data stamps on Ethereum, right? And we cannot compete with financial guys in that regard because we do need much more space for real life instance. So this is the major point. And the second one is human accounts, sub accounts, and stuff. People do get it. This is like domains, subdomains, emails, and developers get it. It's like namespace and stuff. Very useful for the provenance issues.
All right. Yeah, I really like that. Thank you so much, Sasha. This will be it for the current session. Really happy to see you on our stage. Thanks a lot. Looking forward to invite you again.
My pleasure. My pleasure. Take care. Cheers.
And yeah, just in about 30 seconds, we'll be back after a very short transition with the next session. So please stay tuned. We'll be turning on in 30 seconds.